Hi guys, welcome back. In this slide, we're going to take a look at basically how do things float, right? Now in this slide, we've got water, but there's no reason you couldn't use gasoline or alcohol or liquid mercury or any other liquid. And in fact, you could even use fluids. You can find lots of videos online of people floating tinfoil boats in sulfur hexafluoride gas, for example. But we're going to focus on water for the time being. You're going to feel like I'm insulting your intelligence with this slide, but it turns out when we learn about Archimedes' principle and buoyancy, these questions can actually get a little bit confusing. Anything that's lighter than water will, of course, float on the water. In general, anytime you have two substances with different densities, the lighter one will float on top of the denser one. This is true even in cases where we wouldn't typically think about it, like the crust of the Earth floating over liquid magma. The mantle rock has a higher density than the crust rock, which is floating across the top of it. Anytime you've got an object with a higher density, of course, it will sink. This is the reason, for example, that there's very little osmium or very little gold or very little platinum in the crust of the Earth. When the Earth formed and was largely molten, all of those very dense elements sank to the core of the Earth, and so you could find them all there today. You say, well, Cato, I've got some gold jewelry. Where did that gold come from? Why didn't that gold sink? Well, the answer is that gold probably came from asteroids that impacted the surface or crust of the Earth and got lodged in it at some point in the last 4 billion years. A very interesting question is how deep in the water will an object float? Some things clearly just sink to the bottom. A harder question, though, is if you take an object and you stick it in water, will half of it be above the surface and half below, or 25% above and 75%? How do you figure out how high or how low that object's going to float in the water? And like I said, we'll grapple with that a little more when we get to the later section on buoyancy. Final question that I think is kind of interesting. Let's take an object that will sink. I'm just going to plant this seed in your head now so you can think about it. If you drop a 2-pound rock into the Pacific Ocean above the Mariana Trench, it'll take that rock something like an hour to sink to the bottom of the Mariana Trench. So you can ask a question, then you can say, well, what if I have a 4-pound rock instead? What if I drop a 4-pound rock and a 2-pound rock at the same time? Does the 4-pound rock get to the bottom of the Mariana Trench faster? If not, why not? Or if it does, why? What are the variables that matter there? So you can think about that one for a little bit. Final comment on this, water's density, as you saw in the last video or last slide, is 1,000 kilograms per cubic meter, and that's often used as a reference point. And so you should commit that one to memory, that water is 1,000 kilograms per cubic meter.